Today we're going to start talking about slope or rate of change. Now this is really a review, at least initially, of what you did last year. Last year you learned how to count up the rise, count up your y-axis over the run, over your x-axis, and figure out your rate of change or your slope. So the first thing to really get in your head is rate of change and slope. We use those words interchangeably. So starting right here with the vocabulary, using our slope-intercept form of the equation, y equals mx plus b. The m, which is our coefficient to x, the number in front of the x, the m is called our slope. So if I look at an equation, the number in front of the x is the slope, as long as it's in a y equals format. And then we've got the b. The b is called the constant. The reason we call it the constant is it doesn't have a variable with it. It'll just be a number. So we call the b our constant. It's also called the y-intercept. So it's where this line actually crosses the y-axis. So talking about the y-intercept, if we scroll down here and look at this graph, the y-intercept on this graph, we look on our y-axis and we want to know where the line crosses the y-axis. So if we look, our line crosses the y-axis at the 1. So our b, or our y-intercept, is 1. We would write the ordered pair as 0, 1. Just as a reminder, it's an intercept, so there's always going to be a value of 0 for the intercept. Okay, so now let's just take a little bit of a moment and practice finding the slopes for some of these lines. So our first one, we're going to look at number 1. So number 1, we've got points here and here. If we think about what we've learned, let's just take a moment and talk about the different kinds of slopes. So we talked about in class today slope dude. So I'm going to draw this little mountain. And slope dude is about our little skier person, and we always look at our skier person skiing from left to right. So skiing from left to right, when he runs into this mountain, he's going to have to climb up the mountain. And it's going to make him puff a lot. He's going to be out of breath. So puff starts with P. If you're going up the mountain, it's a positive slope. Now, when he gets to the top of the mountain, and he gets to go down the hill, let's put his little hat on him, he's going to say, oh, this is nice, because it's nice to go down the mountain. So nice starts with an N. That means it's a negative slope. So negative slope. Now, when he ends up on flat ground over here, all of a sudden he's having to do a lot of work to ski. And he looks up and he says, wow, this is zero fun. It's no fun or zero fun when you're on a flat slope. So that's a 0 slope. And then if he accidentally falls off this mountain, he's going to holler, ah, all the way down as he falls. And as he falls off the mountain and he screams, ah, that means it's undefined. Okay, so we're just going to call straight up and down when you fall off the mountain. That's called undefined. Okay, so based on what we just talked about, if we look at this very first line, he's fallen off the side of the mountain. So our first slope is undefined. Now let's look at our second slope. We've got a point. I'm going to blow this up a little bit. Okay, we've got a point down here, and we've got a point up here that they've given us. So let's first start by counting up. So we're going to go up 1, 2, 3, 4, 5, 6, 7, 8. So our rise is 8. Now we got to count our run. So from here we're going to go 1, 2, 3, 4. So our run is 4. So our slope, or our rate of change, is 8 over 4. But we can reduce that. We can reduce that down to 2 over 1. That's just a reduction of the fraction. Or we could also just plain old call it 2, because 2 over 1 is the same as 2. Okay, and then let's just look at this. Is this a positive or a negative slope? Well, if we think about our skier guy, and he's over here on the left, he's going to have to go up the mountain. So puff, puff, puff up the mountain. It's a positive slope, so it's going to be a positive 2. Okay, now let's look at this third graph. So first question, is this going to be a positive or a negative slope? Well, it's going to be a negative. If we put our skier starting here at the left, he's going to run into the mountain and go, nice, because he's going down the hill. So we know that this is going to be a negative slope. So let's count our rise. So our rise is going down because it's negative. So 1, 2, 3, 4, 5, because that'll put us on the line with our point. Okay, so our rise was negative 5. And now let's figure out our run. So from here, we're going to go 1, 2, 3, 4, 5. So our run is positive 5. So our slope is going to reduce to negative 1 over 1, which reduces to just plain old negative 1. Okay, so now let's look at the helicopter. And the helicopter, the biggest thing to think about on the helicopter is to look at the scale. Because when we did this in class, I would have people tell me what the rise over run is, and almost everyone missed it because they didn't look at the scale. So let's think about this helicopter. Our helicopter starts out way up here at 35 meters in the air. So when we're counting, is it a positive or a negative line? Well, it's a negative line, so we know that he's descending, or the helicopter's going down. So let's count how far he goes down. He goes down 5, 10, 15, 20, 25, 30, 35. And that's what students miss the most on this. He went down negative 35 meters. And now let's see how long it took him. Well, on the time, it's going by 1 boxes a second. So 1, 2, 3, 4, 5, 6, 7. It took him 7 seconds. So he's going down 35 meters in 7 seconds. If we reduce that, that's going to be the same as negative 5. So he's going down 5 meters every 1 second. Or they could just make the slope be slope equals negative 5. But the big thing is the interpretation. That means that this helicopter is going down 5 meters every second. Okay, now turn the page. Okay, on this page, we're going to actually determine the slope. Instead of from a graph, we're going to do it from a table. So let's keep the same exact principle in mind that we were doing before, which is that we're dealing with the change in our y. So our rise over run, it's the same thing as saying change in our y, our up and down, change in our y over the change in our x, the change in our left to right. So if we write it as change in y over change in x, that'll keep you from making the mistake of getting them in the wrong order. So let's look at our y. Going from the first y to the second y, how much did it change by? Well, negative 2 to negative 2 is 0. There's no change. So our change in y is 0. Now let's go 1 to 2. 1 to 2, it's gone up 1. So our change in x is 1. And let's just check again. We got 0, 1, 0, and 1. So 0 over 1 is my rate of change. And if I reduce that down, that's going to equal 0. So if you think about slope, dude, that's that flat line that was 0 fun. This is going to make the graph of a flat line. Okay, so let's look at number 6. Again, we're going to do change in y over change in x. So let's look at our y. Going from this first y to the second y, it's changing by 8, -8. It's gotten smaller 8 times. If we look again, just to confirm, that one's also by 8, and that one's by 8. Now let's look at our x. This one is actually going up, and it's going up by +2. And if I look, again +2, and again +2. So my rate of change is -8 over +2. And I can reduce that down to -4 over 1, or just slope equals -4. Okay, so now I want you to stop and look at number 7. I want you to pause the video and figure out the rate of change and see if you can figure out what it represents in this scenario. Okay, so this is just saying that our y changed by $1.98 every time our x changed by 2. So it's saying that for $1.98, you can buy 2 songs. Or, reduce it down, every song is 99 cents. Okay, the last thing that we're going to really work on is just practicing defining the slopes and the y-intercepts of these equations. So in this first one, we already have it in the slope-intercept form. The reason it's called the slope-intercept form is because it gives us the slope and it gives us the intercept. So our slope, our m, equals -3/4, and our intercept, our y-intercept, equals -2. And the cool thing is, once we have that information, we could easily graph this line. All we have to do is go to the y-axis, to the -2, and put a point. That's our starting spot. And then we just use our rise over run. So we would go down 3, that's our rise, and we would run 4. Okay, so now let's look at number 9. Number 9, you've really got 2 options. We can use it like it is in standard form and find our 2 intercepts. That's the way I would recommend doing it. Or you could solve it for y. That's the other way to do it. The reason I'm not going to solve this one for y is I can see that I'm going to have to divide by that 4. And it's going to make kind of a fraction. So I'm going to show you how to do it with the x and y intercepts instead. Okay, so if we want, this is just like we did a couple of classes ago. If we want to find the x-intercept, we know an intercept has to have a 0. So x-intercept, we want a value for x, so y has to be 0. So if I go up here and I say I need a value for x, but my y is going to be 0, and the whole thing equals 24. I can cross out 4 times 0, and I'm just left with 6x equals 24. Divide both sides by 6, and my x equals 4. So I have my x-intercept. Now I'm going to do the same thing for my y-intercept. So my y-intercept, I'm going to put it over here. Y-intercept is going to have a value for y. So I know my x is going to be 0. So again, I'm just going to do it right up here. And I know that 6 times 0 crosses out. So what I'm really left with is 4y equals 24. And if I divide both sides by 4, I get y equals 6. Okay, so my y-intercept is 0, 6. So I already know what the b is. The b is 6. And then if I just think about how to graph this. I know my two intercepts. So if I look at my graph, I know that my x-intercept is out on 4, so I'm going to go 1, 2, 3, 4. And I know that my y-intercept is up on 6. So he's way up there. If I draw this line, I can already see that this is going to be a negative. So my slope is a negative something. So we just do our rise over run. Our rise was 6. So 1, 2, 3, 4, 5, 6. We're just counting down here from the top of our graph. So we count down 6, we count over 4. So our slope is negative 6 over 4, or that would also reduce to negative 3/2. Okay, and let's do number 10 also. Okay, on number 10, because we already have y doesn't have a coefficient, it's just a 1 in front of it, it looks like it'll be easier to go ahead and just solve this thing for y. So I'm going to draw my line down the middle. I'm going to circle what I'm solving for, which is y. It's a positive y. So I'm just going to minus 3x. Now, here's where I saw most of you guys going wrong during the review. 3x is not a like term to 0, so I'm not going to put it under the 0. I'm going to put it off to the side. And I've got y equals 0 minus 3x. Okay, so let's think about our slope-intercept form, because this is in backwards order. We know it's y equals mx plus b. But if you notice, my x term is over here, so I'm going to go ahead and just put mx under there, and I'm going to put b under my 0. That just reminds me that it doesn't matter which one comes first. The one with the x has slope attached. Okay, so I need to know what my m is. My m is going to be the negative 3. And then my b is 0. Okay, for the next one, we've been given an equation. Again, the y has a coefficient of 1, so it's going to be easier to just go ahead and solve this thing for y. So I'm going to draw my line, I'm going to circle my y that I'm solving for. I'm going to say minus 2x on both sides. Now 2x is not a like term to 2, because 2 doesn't have a variable of x. So I'm going to put my minus 2x over here beside it. I'm going to bring it all down, and I get y equals 2 minus 2x. Now again, this one looks backwards from our normal y equals mx plus b. So I'm just going to write it below it. Y equals, my mx is over here, my b is over here. That just keeps everything straight in my head. Okay, so let's start by identifying our slope. Our slope is negative 2, because that's our m. So negative 2. Our intercept is positive 2. So let's get this graphed. Okay, in order to graph this, first thing we have to do is say, all right, we're beginning on our y-intercept. So I'm going to go to my y-axis, and I'm beginning at positive 2. So I'm going to put my dot, my beginning point, on positive 2. Now I have to decide how to graph the slope of negative 2. Now in class we had a lot of discussion over this. And some people wanted to put negative 2 over 2. So let's just look at that and see what's wrong with that. Negative 2 over 2, when you simplify that, that equals negative 1. Now, is our slope negative 1? No. Our slope is not negative 1. Our slope is negative 2. People just see those two 2's there and decide that that must be what it is. But I want you to think logically about this. Your slope whatever your fraction, rise over run, you use, it still has to reduce and equal to what the slope is. So when we have something like a -2 slope and it's not over anything, it's always going to be over 1, because -2 over 1 still equals -2. So we know that that's the correct slope. So our rise over run, our rise is -2, our run is 1. We're getting that from our rise over our run. Okay, so we're going to go down from here. We're going to rise -2. So let's use red. We're going to rise -2. We're going to run 1. And we're going to put our dot. Okay, so now I have my 2 dots. I can draw my line. And if you notice, this line is a negative line. It's a skier going down the hill. So let's identify our x-intercepts. So we need to know where our line is crossing the x-axis. It's really hard to tell with the way I drew the line, but we drew our point right there at the 1. And so that's going to be our x-intercept. And then it says identify the 0. Well, the 0 is always the x-intercept. Maybe the easiest way to come up with remembering the 0 is that the y-intercept already has a job. It's the b. It's in the equation. It's our constant. It's already got a job. So the x-intercept is going to be the one that's going to be our 0. Okay, and then if we just look at these last 2 questions, it's asking what form this equation was given in. Well, it was actually given to us in the standard form, where our x and our y were over on one side and our constant was on the other. And what we did was we went and solved it for the slope-intercept form. We solved it for y so that we could see what the slope and the intercept were. But just like we did up above on, I think, number 9, we could have also found the intercepts. If we had just taken the time to find the intercepts, it would have been just as fast and easy to graph this line. So play with both ways, because sometimes you'll get a problem where you see it easier to just find the x-intercept and the y-intercept, and sometimes it feels faster to just solve it for y. But have both of those tools as options for you. If you have any questions on this, come into tutoring either before school or after school and make sure we get everything cleared up.